that I have 2 bags of M&Ms. Well, little bags of M&Ms. They're like the little guys, so there's not that many in them. Let's say that one bag contains 20 M&Ms, 20 total, and the other bag contains 30. Let's make nice, pretty numbers. So there's a total of 20 M&Ms here and a total of 30 M&Ms there, and we're gonna mix them together. So this is gonna be what I call mix number 1, and then mix number 2. And then that's going to get us to our final mix. And well, there's sort of a conservation of mass here, right? There's 20 M&Ms there, 30 M&Ms there. I bring them all together, I end up with 50 M&Ms over there, right? Okay, so now let's say that we kept track of a particular color. Let's say that out of the 20 M&Ms, right, there's a bunch of M&Ms sitting in here. 1, 2, 3, 4, right, so a bunch of M&Ms are sitting in there. Let's say that exactly 5 of them are brown M&Ms. 1, 2, 3, 4, 5 brown M&Ms. And the rest are something else. So 1, 2, 3, 4, 5, so then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So there we go. There's 20 M&Ms total, and 5 of them were brown. Let's go over here. Let's say that 15 of them are brown over here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 50 of them are brown, and the rest are not brown. So. Okay, so then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 20. There we go. So there's 30 of them, 15 are brown, and 15 of them are not brown, they're other colors. So then when we bring them together, we should have a total of how many brown ones?
20.
20 brown ones. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 17, 18, 19, 20. And how many of the rest? 30, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, so I'll make this guy bigger. Okay, so there we go. Now let's think about the percentages that we have going on here. So what percentage brown was the first mixture?
25%.
Okay, so as far as, let's go back and do the actual counting ones. So there were 5 brown. That is a percentage or anything. There were just 5 brown ones here. 1, 2, 3, 4, 5. And we said there were 15 brown over here. And so that equaled a total of 20 brown. Right? Does that make sense? 5 from here, 15 from there, 20 total. Okay, let's look at the percentages. So there were 5 out of 20 brown ones here. So the percentage was 5 divided by 20 percent brown. So this is going to be equal to 0.25%. So I can say there's 25% brown in the first mix, 25% brown in mix number 1. What about mix number 2? There were a total of 15 out of 30 brown. 15 out of 30, which is equal to 1 out of 2, which is equal to 50% brown. 50% brown, brown in mix number 2. And then over here, at the end of the day, we said that there were how many? 20 brown out of 50. Oops, 20 brown out of 50, which is equal to 40% brown in the final mix. Okay, that's true. And well, of course, we have the fact, the original fact, that 20 plus 30 equals to 50. So we have a bunch of stuff here. So 20 plus 30 did in fact equal to 50. But notice how this middle one doesn't really quite add up, right? I mean, the natural desire is to be able to put a plus here and say that the 25% brown from the first mixture plus the 50% brown from the second mixture somehow equals 40% in the final, and that just doesn't add up, right? 25 plus 50, that should be like 75, and that doesn't work out. So this is a true statement, the first one. 5 brown plus 15 brown equals the 20 brown. And the final one is also true, that the original 20 mixture plus the 30 mixture does equal to the 50 mixture, but this one doesn't quite work out. Okay? However, we can find out that answer if we know the 25% and the 20. So if somebody told you there was 25% brown in this mixture and it's got 20 total M&Ms, you should be able to figure out that there are in fact 5 brown ones in there. Or if someone told you here's a mixture of 30 M&Ms and 50% of them are brown, you should be able to figure out that that means that there are exactly 15 brown ones. So there are various pieces of information that are going to be given to you, and you're going to have to use them to be able to come up with 2 true statements, which are usually these 2 kinds of things. So the word problems are going to say something like, a mixture of 25% brown M&Ms is combined with a mixture of 50% brown M&Ms to make a final mix of 50 M&Ms that's 40% brown. That's the kind of word problem you're going to get. And so, you know, in that word problem, we were told this, we were told this, we were told this, we were told that, right? So there are various pieces of information that will be given to you, and based on the ones that are given to you, you should be able to piece it all back together and be able to get to a point where you have these 2 true statements, and then be able to answer whatever question they're asking you for. Okay? So I hope that helps. In a way of organizing this, I would say I would take this exact same thing and organize it this way. So I like to make circles for these, and I like to make sad faces because they're really hard. Okay, so mix number 1, mix number 2, and the final mix. Okay. So we knew that the first mixture was 25% brown, so put the percentage in there, 25%. You might want to write it down as its decimal representation at this point so that you don't, make a mistake down the road, but if you know that you have to convert it, then that's fine too. We might be told that the second mixture is 50% brown. So we put that percentage there. And we might be told that the final mixture is 0.40, 40% brown. So the ones here do not add up, right? Because as we saw from before, 25% plus 50, that'd be like 75, not 40. Okay, you might be told some of these things, like you might be told that that guy is 50. So if you're told that the final mixture has 50 total M&Ms and 40% are brown, then we can multiply these 2 things, 0.40 times 50, and we would end up with 20. Good. So 20 brown ones. 50 total, 40% brown. That means that there must be 20 brown ones in that mixture. Okay. And then, well, we're going to have to come up with something here. We might be told what this value is, we might not. If we don't know what that is, then we can rewrite it as an x. and then write that as a y, where x represents the amount of M&Ms that are in this mixture, and y represents the amount of M&Ms that are in that mixture. So in order to get how many brown ones there are, we'd have to multiply this times this. So 0.25 times x plus 0.50 y. Good? And then the other true statement that we know is that x plus y must be equal to 50, right? Because they add up to 50, the conservation of the actual M&Ms. You know, I'm just repeating the previous problem, so we already know that this is 20 and this is 30, right? That's the numbers that are supposed to go there. So we would know that x plus y equals to 50. And there are two equations that we'd have to come up with. And now we have two equations with two unknowns. We can use substitution to plug one into the other and evaluate it that way. No, that's fine. So we can use substitution to plug one into the other and solve for it and come up with a function of a single variable. Good. Questions? Okay, so this is the general idea, just using this M&M stuff. So if we have one mixture plus another mixture, there are two things to consider. The total quantity of all of it for both of them, and there's a conservation of mass there. And the other thing to consider is the quantity of the thing they're asking you to keep track of. In my little example, it was the brown M&Ms. And they might be giving you a percentage of the total mixture that is a particular thing. It might be a particular chemical, like we'll see in a second, alcohol. Or it might be certain like almonds in a mixture of trail mix or something like that. So there's a variety of things that they'll ask you to keep track of, and the percentage that they give you keeps track of it. So you can use the total and the percentage to figure out how many of the individual things that you're keeping track of there are in that mixture. And then there's a sort of a conservation of mass again with the item that you're counting. Okay? All right, so hopefully that will help to make sense of the following problem. A chemist wants to mix a 10% alcohol solution and a 20% alcohol solution to make a 12% alcohol solution. How many cups of each solution must be mixed to make 5 cups of a 12% solution? Okay, so we got two mixtures happening. Instead of counting brown M&Ms, we're counting what? Alcohol, right? Pure alcohol content. So we got one mix, there's some alcohol in there, 10% of it. There's another mix, there's 20% alcohol in there. I'm going to bring them together and I want my final mixture to have 12% alcohol. Remember that the percentages don't add up. I can't just have percent plus percent equals the final percent. So it's not that easy. I have to figure out how much alcohol there is in each individual mixture in order to figure out this solution. Okay, so let me erase this thing here. Put it all together. Alright, so we're going to have mix number 1, and I'm going to add it to mix number 2, and that's going to be equal to my final mix. And they all have certain percentages associated with them. There's certain quantities, volumes associated with them. In this case, we're talking about cups. So keep track of your units. So what should we put where? First mix is 10%. Okay. Second mix is 0.20. And my final mix needs to be 0.1, 12%. Good. Okay. What else do we know? How many cups of each solution must be mixed to make 5 cups of 12%? So the final mixture has a total volume of 5 cups, right? Good. I want my final mixture to be 5 cups. Good. Now what? Well, since we don't know these two things at this point, define them as X and Y, where X is the number of cups of the 10% mixture, and Y represents the number of cups of the 20% mixture that are going to be brought together to give you 5 cups of 12%. Good? Alright, so if we multiply these two things, 0.12 times 5, what do we get? 0.60. And what is that? 60%? 0.60. 12% what? 12% alcohol. So when I multiply, what did we get when I multiplied the percentage times the total number of M&Ms? It gave you how many brown ones there were. So in this case, this gives you how much pure alcohol there is, right? It's hard to visualize it with the liquids because it's all mixed in there, but inside that mixture, that solution, there is pure alcohol, and then there's other things. The rest is probably water, or it could be other chemicals or whatnot. But alcohol on its own is an actual chemical, and you could have 100% alcohol. And that's what this is. If this mixture, if this cup, this 5 cups was a solution that had 12% alcohol, it means that inside there is 0.60 cups of pure 100% alcohol. Good? Questions? Right? That means that this is a volume quantity, not a percentage. It's 0.60 cups. A little bit more than half a cup of pure alcohol is in there in order to make this a 12% alcohol. If it had been exactly 1 cup of pure alcohol and 4 cups of water, that would give you a mixture that's 5 cups, and it would be 1/5 alcohol, which would be 20% alcohol. Got it? Good. Okay, so now over here, in order to figure out how much alcohol there is in Y number of cups, well then you would just multiply them together and get 0.20 Y. That's how much pure alcohol is in this mixture. And then over here, 0.10 X, that's how much alcohol there is in this mixture. Good, like the pure amount of alcohol. And then the other true statement we know is that X plus Y must be equal to 5 cups. Good. So we have 2 true statements. This one and this one. Good. So we can solve for it by either the substitution method, the elimination method, or we can graph them both and find the intersection with our calculators, right? So, why don't we solve it with either the substitution or the elimination? We'll use the calculator in a little bit. Substitution? Yep. Okay, so if we're going to use substitution, we got to pick one of the equations, right? We got 2 equations. Back over here. We got equation number 1, equation number 2. We got to pick one of the equations, solve for one of the variables, and then plug it into the other one. So what's the easiest thing to do? Pick equation 1 or equation 2? 2 and solve for, they're both the same, right? Solve for X, solve for Y, they're the same thing, just move it over there. And then plug it into the other equation, thereby getting a new equation that only has one kind of letter in it, and then you can solve for that value. So we had X plus Y was equal to 5. Right? The amount of cups for the 10%, the amount of cups for the 20% gave you the 5 cups in the final mixture. So let's say we solve for X. X equals to 5 minus Y. And then we're going to take that and plug it into equation number 1, right? This one is equation 2. Equation 1 was 0.10 X plus 0.20 Y was equal to 0.60. Okay. So we're going to take our newfound description for X and plug it into there. 0.10 times 5 minus Y plus 0.20y is equal to 0.60. Okay, so then we multiply, distribute, combine like terms. So this is 0.50 minus 0.10y plus 0.20y equals to 0.60. Combining line terms, so now we only have y's in here. So now we have a new equation that only has y's in it. We can solve for y. Move this over there. We get minus 0.50 minus 0.50. And combining these two, we get 0.10y equals to 0.10. So y equals to 1. Good? Questions? Questions? No? Okay, so now that we found y equals to 1, we can go up to this equation and solve for x. So x equals to 5 minus y, and so x equals to 5 minus 1, and so x equals to 4. So we found our solution. If we let x equal to 4 cups, so 4 cups of 10% alcohol mixed with 1 cup of 20% alcohol will give you 5 cups of 12% alcohol.